Hello, this is David D. Hilster. I am a critical thinker, dissident scientist, and if you are not science woke, then this is the place for you. There are literally thousands and thousands of scientists from around the world that have been working for decades outside the mainstream, who have identified problems, fixed those problems, and who are proposing new theories and models. You won't find anything like this on the internet, believe me, so just go right down below, right down there, and you'll see the subscribe button, the little bell next to it, so you can click that, and you will be alerted to when our next video drops. Well, some of my science friends and one of the great heroes of dissident scientists, a critical thinker, a science woke person is Stephen Carruthers, and he had this on his Facebook page, and when I saw it I said, this is a once in a couple year happening. What is that? When someone in the mainstream challenges something important in the mainstream. In this case, Danish physicists claim to cast doubt on detection of gravitational waves. Of course, this is LIGO's response. LIGO, of course, is the experiment that supposedly detected gravitational waves and gave 3 people Nobel Prizes. And LIGO responds, there is absolutely no validity to their claim. That doesn't sound very technical to me. But anyways, we're going to go through this article because it is chock full of what is wrong with mainstream physics and cosmology in this case. The Nobel Prize-winning first direct detection of gravitational waves announced in 2016 is being called into question. LIGO calls shenanigans. Oh, this is amazing. And I'm sure this guy is going to be a neutral reporter. Ha! Not. So let's go forward here. The first direct detection of gravitational waves was announced on February 11, 2016, spawned headlines around the world, snagged the 2017 Nobel Prize in Physics, and officially launched a new era of so-called multi-messaging astronomy. What does this all mean? There's a couple of things you can read into this. Number one, the detection of the gravitational waves was in February 11th, 2016, and they got a Nobel Prize the next year. It's almost like, okay, you guys, when you say you're going to detect this, and oh, we detected it, and of course they're going to dispute that. But that's quite amazing how they just went that, and there's probably lots of other things because these people, these Danish scientists, physicists, think they didn't detect anything. So let's give them the Nobel Prize before they really show it's a bunch of baloney. Also, you notice it said so-called multi-messenger astronomy. What that means is they get signals in different ways. Gravity waves, radiation. Okay, and we're going to talk a little bit about some of the problem with that later on. But a team of physicists at the Niels Bohr Institute in Copenhagen, Denmark, is calling the detection into question based on its own independent data analysis conducted over the last 2.5 years. Niels Bohr Institute. This is not like, Dave D. Hilster in his backyard, These people are somewhat have some clout. Let's keep going forward. A new scientist, let's make this a little bit bigger. Oh no, I moved the world. I moved me. Nope, let's move this here. There we go. A new scientist report, as News Scientist reports, the group thinks that the original gravitational wave signal detected by the Laser Interferometer Gravitational Wave Observatory, LIGO, was an illusion. Yay! Boy, wasn't it an illusion. I have one. Oh, and by the way, if you want to read right up there, I have the link for you to go to me talking about the LIGO detection. I have already talked about this, but this is much more interesting because this is a fight going on, and you're going to see how they try to put this down, all the confusion that's in this article. So the magazine oddly touts this as an exclusive, but group spokesman Andrew Jackson has been banging this particular drum for a while now, after first experienced misgivings about LIGO's analysis as presented during the February 11th, 2006 press conference in Washington, D.C. Boy, I think this is really great because I'm a progressive politically. Don't care what your politics are. No, I'm just saying. But I don't have a whole lot of trust in the people who control our government, which are the people with lots of money who pay all our politicians to do what they want. But anyways, of course, you got to go to Washington, D.C. because I guess if you're going to shovel, to the masses, you might as well go right to the place where they shovel more than any other place on the planet. So it's sort of ironic in my opinion. The group's original paper was published in the Journal of Cosmology and Astroparticle Physics in August of that year, and there has been considerable back and forth within the physics community about Jackson's claim since then. Andrew Jackson and his group have been saying for the past few years that LIGO's detections are not real, says a LIGO executive director from Caltech. See, here's one of the things they do. They always want to be polite, because what they know now is if they fight, then they seem like they're on the defense. So now they're really calm about the way they lie. Sorry, sarcasm. Their analysis has been looked at by many people who have all concluded there is absolutely no validity to their claims. All of a sudden, he's talking around like, my little boy came up to me and says, Dad, Santa Claus is real. And I said, okay, let's look at the evidence. But I went up to him and says, there's absolutely no Santa Claus. All of a sudden, this gets almost vicious. One of the things you have to say in science always is that nothing's ever right. We're just going to be maybe more right than we were before, and we can never say all the foundations that we have built are correct and they're immovable. That's just. But science doesn't work that way. Not today. They're now okay. So he characterized. And he says, characterized the New Scientist article as very biased and sensational. So there you go. It's not even talking about the science. This is total emotional, because when you say absolutely no validity and you say to their claims, you are absolutely attacking them at an emotional level and not at a scientific one. So you can tell it's emotional to them because, heck, hey, let's detect it. Give us a Nobel Prize before they can prove us wrong. LIGO spokesperson David Shoemaker of MIT, see MIT, Caltech, well, they're from the Niels Bohr, come on, thinks the controversy all boils down to misunderstanding about LIGO's method for analyzing data. You think that's the whole thing? Sometimes I just really think these people are smoking crack, or they don't even listen to their own words. Of course that's what it is. The entire experiment is about analyzing data. Oh, this whole thing is shaking. I'm shaking my desk and everything. Sorry. Oh my gosh. So it says misunderstanding about LIGO's method for analyzing data. Jackson et al. Came to it skeptically. I think here we go again. Here's this it's okay for kids to believe in Santa Claus, but then they bash it to him. Jackson came to it skeptically. And I think skepticism in science is a really important thing. You have to question results. But these are complicated data. They are not simple to understand. Certainly nothing they've done gives us any reason of doubt to doubt our results. Let's look at this. This is some of the arguments they constantly make, and this is why I am your science therapist. This is why you're watching this channel, because you don't necessarily know these things. But listen to this. But these are complicated data. See this book, The Higgs Fake, which you should read. And of course, if you didn't read it, go right up here, and you'll get to the link about The Higgs Fake, which I've done a couple in the series, and you should read this book. And he talks about this too, unnecessary complications. And that's how they fool us. They say it's so complicated you can't understand it. They are not simple to understand. You can see that. Complicated, not simple to understand. This is the same way politicians go and say, oh yeah, we got to give tax breaks to the rich because it trickles down. The billionaire, he's going to buy 10 million pairs of pants, and that's going to trickle down. So what they do is they have their talking points, and their talking points, oh, well, they got to understand. Well, Professor, I don't know what to say. They actually have some good arguments, and we may not have... Shut up! What you should do, here's what you say. You tell them it's complicated data, and it's not simple to understand. Certainly nothing they've done has any reason to doubt our results. I don't know why I get into that kind of accent. Sorry, anybody who has that accent. I'm not trying to make fun of you or anything. It's just character acting there. Oh my gosh, let's make this a little bit bigger here. I was all these different sizes. While LIGO has gained, not entirely undeserved, reputation for excessive secrecy, What? Shoemaker says the collaboration has spent a great deal of time interacting with Jackson and his group over the last 2 years to improve their understanding of LIGO's methods, including extended visits to the Niels Institute, inviting Jackson et al. To discuss in depth in teleconferences with the LIGO team members. So if LIGO's response if LIGO's response whenever that drum begins beating sometimes comes off as a bit exasperated, there's a very good reason for it. What's really going on here? They're saying a couple of things. Number one, they're saying, we have a reason, we're in a secret. Well, this is a ploy. Later on, you will see why. But this is a ploy. A spoiler for a few minutes from now. But executive secrecy is a way they hide their data. That's what they do with the Large Hadron Collider. They don't allow you to see all the data because if you did, you could dispute it. So he's saying, we have spent a great deal of time interacting with Jackson and his group over the last time to improve their understanding of LIGO's methods. I should have highlighted that right there, this sentence right there, that part of it, to improve their understanding of LIGO's methods. What does that mean? They need to teach Jackson, you don't understand it. Your analysis has to go this way. Well, but it's like, no. You got to do step one. Well, that's not the problem. Well, no. And it's basically capitulation. What they want to do is they say, we've went there. We try to teach them, but they won't listen. No, the problem is they're not listening on the LIGO side, because you can tell by the way they are phrasing things that they are an emotional level. There's absolutely no way. And then when they do, they just say, well, we know it's right. Let's just try to argue it away. But here they are. They said, we have made 2.5 years of effort to teach them how we know what we have found is what we found. Help us, please. That's why I'm your science therapist. I take you through these things. It's sad, but... So anyways, let's go to the next one. My goodness, we still have like 10 slides. Don't go away. There's great stuff. The end is the best. So stick around. I will move fast here. Reasonable doubt. This is a field long riddled with doubts in the 1960s. And he goes on and he talks about how they tried to find it using this cylinder. And it's sort of like pinging on this big cylinder. And that ping would tell us, well, Weber claimed he had detected a signal in 1969. Alas, nobody else could replicate that result. And Weber's professional reputation never fully recovered. You notice they don't talk about any of the science. They talk about his reputation not fully recovering. This is where it comes down to ego. It has to do with reputations, egos, and very little to do with science. Why isn't he talking more about it? That's this ending thing. When you write paragraphs in journalism, that ending sentence is the most important sentence because it usually sums up and gives you some conclusion about what you've read. And the conclusion is their reputation was ruined. They were spit upon. They were deemed with an IQ of 46. Then in 2014, the BICEP2 collaboration, which hunts for telltale signatures of gravitational waves and cosmic background left over from the Big Bang, announced that it had detected indirect evidence for the ripples of the fabric of space-time. Now, this is, of course, real suspect because, first of all, it's indirect evidence and it's detecting ripples in the fabric of space-time, which, of course, my contention is with, if you go to that video I had pointed out earlier that I did on LIGO, just go Dissident Science LIGO, you'll find it. Basically, you can't do any of this if you don't have any physical explanation for light, gravity, gravitational waves. That's fine. Announced that it had direct... Anyways, much fanfare ensued. Within weeks, however, serious doubts began to emerge. Ultimately, it turned out to be that the BICEP collaboration had mistaken clouds of cosmic dust for a signal. So they're all ready to pilot on the other one. The blow is crushing. Gravitational wave community was sufficiently burned by the BICEP2 debacle that LIGO opted for extremely caution and secrecy. See, that's why that's why you subscribe to this, because you don't have time to go all through all this stuff. And I've been through and I read through this, so I can tell you what's going. Come on, extreme caution and secrecy. Why? So that they can't be shown wrong. And even with their secrecy and all that stuff, they are being shown wrong. Ironically, a big part of the reason collaboration is viewed with distrust in some quarters. Its researchers spent several months between signal detection and the official announcements to double, triple, and quadruple check their analysis to guard against another false detection. Guess what, folks? It is a false detection. The reason is because they don't know what they're detecting. They don't know what space-time is, so what in the heck, how in the heck could they detect a ripple? And they have no model for anything. Yeah, did they detect something? Yeah, there was a blip somewhere. What it means is like no one knows. Okay, so how could this happen? How could this happen again? First, it is highly unlikely that it has happened again. That's meaning, oh, it's wrong. No, it's highly unlikely that it has happened again. Obviously, this writer is a neutral, unbiased writer. Not. The answer is the separating signal from noise is very, very difficult in this kind of analysis. The signal is extremely faint, on the order of a billionth diameter of an atom. That's why you need such sensitive detectors to pick them up. That's awfully small. Noise. Oh, you're going to hear about noise at the end. Stick around. The big conclusion. I thought this was just great. Here it is. LIGO's February 11th, 2016 press conference in Washington, D.C., where more BS is shoveled onto the human race than any other place on Earth. So it's very, like I said, it's very gratifying they did it there. When its team announced the first detection of ground waves, I'm going to tell you, take a look at this picture right there. Take a look. You take a look at those people. Now, we are humans. We are expert systems. We are artificially intelligent in detecting. We are the best detectors in the universe of people's facial expressions and reading them. Does that look like a group that found something extremely important? It's almost more like, let's get this done. Let's get it out there. Yeah, it's all on a house of cards and quicksand, but no one knows. And let's go to Washington where that kind of behavior is welcome. So on September 14th, 2015, both detectors pick up a signal with milliseconds of each other for the very first time. The waveforms of the signal serve as an input, as an audio fingerprint. Okay, this is just absolutely great. Okay, the waveforms of the signals serve as an audio fingerprint. Okay, these are blips. Okay, these are basically just blips on their. You saw that, right? Let's just go back on one. See the blips? There it is. Okay, see what those blips are? Here's what they are. In this case, evidence these blips for two black holes spiraling inward toward each other and merging in a massive collision event, sending powerful shock waves across space-time. Seriously, these guys, they do drugs. They have to be doing drugs. They have to be smoking or smoking mushrooms or eating mushrooms, doing crack, doing something, some hallucinogenics, because how these people come up with these, it's two black holes, not one, spiraling inward toward each other, not like, it's like, this is what it's got to be. I don't know. I'm sorry. I just want to shoot myself. That is the signal that Jackson's group mostly strongly disputes. You think? Correlated noise. Gravitational. Okay, here we go. This is one of the great points I said. Stick around. Gravitational waves travel at the speed of light, but since detectors are so far apart, there should be a slight lag time and a small adjustment in amplitude to account for the curvature of the Earth. The signals will be correlated in data. The noise, however, should be not correlated. The Danish team concluded from its analysis that the noise was correlated at both detectors for Jackson called it sufficiently distinguished between signal and noise, hence the validity of the detection itself. So this gets down that the signals will be correlated. And what are they saying? Well, we'll see later. But I wanted to talk about the speed of light. So we have the speed of light and the speed of gravitational waves. Okay, so we have gravity traveling at the speed of light, gravitational waves in the gravity traveling at the speed of light. Now think about that, folks. If gravity is traveling at the speed of light, how are waves in the gravity traveling at the speed of light? That model makes zero sense. If it's a particle model, maybe, like my father and I, but they don't have a model. So, gravity is a graviton. Gravity is space-time curvature. So if you have space-time curvature, there's nothing traveling. Gravity isn't traveling. But then they say it's gravity travels at the speed of light. What? Space-time curvature is what caused gravity. It's sort of like, it's not moving. But there's gravity, gravitons, and they say often, and we actually have experimental proof or experimental evidence that gravity travels at the speed of light. Well, how do we know that? Because the eclipse and the effect of gravity the eclipse and the effect of gravity from the eclipse arrive at the same time, at the speed of light. But you have space-time, which doesn't travel. You have a graviton, which does travel. You then have waves through the space-time. What are they talking about? Their model's all mixed up. It doesn't make sense. Why? Because they don't have a model. The Danish analysis is just wrong. Okay? You see how scientific that is? These are statements of when people get emotional. And they say, well, we're frustrated because we've been trying to tell them how we detect it, and they didn't buy it. They didn't swallow it. They didn't capitulate. That's what you have to do in physics today. You can't question all the paradoxes and all the problems and all the shortcuts that are wrong, all the assumptions that are wrong. In a series of calculations for the black hole by Stephen Carruthers, he shows step after step after step that makes these assumptions and leaps that are just absolutely impossible to accept. Why do? You capitulate. So the Danish analysis is just wrong. Okay, that's what they're saying. Blah, blah, blah said. Blah, blah. It says, adding that Jackson's group used a simplified, now see, here we go. You children, you use Rector set to try to build SpaceX's big effing rocket to go to Mars. And that's why. You simplified analysis and made some very basic mistakes because you're kids. All of this kind of talk is demeaning, is trying to diminish people. It's not talking about science. There shouldn't be anything about talking, but you shouldn't be saying anything like simplified, basic mistakes. They try to say it, but then when the people explain it to them, they don't buy it. They're not listening. The LIGO team is only there to defend everything that it's done. It's never going to capitulate. They're going to go to their death clutching their useless Nobel Prize 100 years from now, which will be known useless. Oh yeah, remember they gave a Nobel Prize for gravitational waves? They didn't even know what gravity was. So, enjoy your ego and your fun now, because when you're dead, if there is a life after death, you can look down and see yourselves being relegated to the flat Earth society, okay? While Jackson has considerable experience in signal analysis of large data, he does not work directly with gravitational wave. Yeah, he doesn't, but he worked on these, which are very different beasts. They are coming with a tool set they developed for another field. Yeah, they're coming in with their experience with looking at data, and yes, they have a different perspective. That's the idea! Perhaps the best argument in favor of the validity of electives is that they've made several detections. Now, this is very interesting in the sense. They said it was a glitch. There's two things that are going on. Jackson and his team are saying, well, the moment you calibrate, you synchronize them and calibrate them, you look at my collar. It's been all wrong the whole time. If my mom was alive, she would say, Dave, your color's wrong. That you would, they are talking about, Jackson is saying, look, when you do this particular analysis where you synchronize and you look at them both, you're causing them to have a false detection. And they're going to be doing it again. Can they be detecting something? Will the detectors they have actually detect something very close to one and the other? Absolutely. Do they know what that is? No. That's the whole thing. They have no idea. You can say what you want. It's their unicorn world, their Harry Potter world that they've constructed without a model, with a paradoxical, unintelligible, impossible to understand, not because it's complicated and paradoxical and illogical and has conflicting problems within itself. It's not self-consistent. That's the problem. Okay, so moving on, we have only 3 more slides here. For and I told you at the end is really good. For all the sound and fury, the Danish group's position is a minority. Okay, here we go. Groupthink. The majority wins. Even those physicists who went on record with New Scientist in support of the Danish Analysis still think that, in the end, LIGO's results will hold up. Yeah, because, we're sort of all wanting that Nobel Prize. And if I'm going to come along and I propose my unicorn, I want to get that Nobel Prize the next year before they can dispute it, I'm going to play along, Who cares? This emphasis on the need for independent confirmation of LIGO's, it says, scientists who report the Danish Analysis still think, in the end, that LIGO's their emphasis is on the need for independent confirmation of LIGO's analysis. I'm not sure what that means. Don't care, because it's not as interesting as what's coming in the next last two paragraphs. On that point, people seem to be in agreement. But Ritz counters that the complete data from the first round is already available online. According to Shoemaker, this includes the relevant time series and programs used, but it's not a trivial matter. So here he's saying, oh, we've got the raw data, but and we have the programs used for it, but we're telling you it's not a trivial matter to use them, and we'll have to train you to how to do them. And if you change them or you argue with them, that's not right. So anyways, Caltech even held a training workshop. See, there you go. Workshop on how to deal with the gravitational-wave data. So we're going to tell you how to interpret it to show you and that you've detected too. They're going to have kits for children. Analyze this data with machine learning in your university, and you too can show this is a detection of a gravitational wave. Two of them going together. One's blue, one's red. They're over here, and they actually. It's a pretty far cry from asking physics community to take its analysis on faith. As Jackson claims. You know what the psychologists say when people are lying to themselves? They always accuse their enemies of what they do. Like, here we come. This is worth it. Got it in yellow. Don't read the yellow first. Andrew, and contrary to Jackson's assertion in the article, a technical paper really is in the works. You notice it says, really is in the works. We're really going to argue this in a technical paper about this whole problem. As in the works at LIGO collaboration, detailing how it handled the noise in its data. And this is just amazing. This is their last paragraph, and this is their conclusion. Noise just hasn't been a top priority. You have to understand, signal detection in particle physics, and now in quote-unquote gravitational waves, is all about noise. Because, as they say, the universe is noisy. The idea of detection is detect something that isn't noise. Noise just hasn't been a top priority. That's just like saying, oh, Newton's laws of physics and force just weren't a top priority on that building we built. Yeah, it fell down, but that's not why. Schumaker concedes that he has given LIGO a needed nudge to complete it. What he's saying is, oh, well, Jackson, he did something, so we'll write the paper and squash this. So 10 years from now, my grad students can say, of course. Well, they'll have a student who's upstart saying, yeah, I looked at Jackson's stuff, I agree with it. This is detecting nothing. Oh, no, but here's the paper. Read it, and if you don't understand it, you won't pass. You won't get your PhD. We've been careful to write a paper that is not a rebuttal of Jackson at all. See, there we go. They don't want it to be a fight. Since I don't think that would be very useful for the community. You know why? Because they'll put that point where they can be knocked down again. So they're not going to do that. Instead, it'll be more didactic about the specific points where we see they had. Now you get an idea of what happens when someone within the science community challenges people inside the community. This is when physicists in mainstream challenge physicists in mainstream. And I will guarantee that these guys, Jackson, these Danish physicists, are probably experimentalists who probably disdain theoretical physics. You have to understand, when I interviewed Dr. Kesley it was at Stanford Linear Accelerator, and I asked him at breakfast, I said, so what's it like to be a theoretical physicist? He turned to me and says, don't ever accuse me of being a theoretical physicist. This is an experimental physics in the particle accelerator itself. So we have to understand these are minority opinions. Extreme. The vast majority of physicists, the almost unanimous consensus of scientists and engineers and NASA engineers, these kind of people, they don't believe all this humbo jumbo. Humbo jumbo? I just made it up. Anyways, I'm Dave D. Hilster. So I've gone on long enough. Stay critical, stay thinking. I am your science therapist. Ciao for now. Getting you science woke.